Hello students, myself Dinesh. Welcome to Process Control lecture series. In my previous lecture, I start the basic analog controller. So in that lecture, we understand what is analog controller and we discuss about the on-off controller, that means two-position controller. Then we discuss about the P controller and I controller, that is proportional and integration controller. Now in this lecture we discuss about the derivative mode controller, that means derivative controller. Then we discuss about the composite controller modes, that means composite mode, that means the PI, PD and PID controller we discuss in the composite controller. So now we start about a derivative control mode, that means derivative controller. So this is the figure of or the diagram of the derivative control mode. The derivative mode is never used alone. We know already because it cannot provide a control output when the error is 0. So this is the main limitation of derivative control mode. We already know we cannot use the derivative controller alone. That means we have to use another controller with the derivative controller because it can provide a controller output when the error is 0. The analytical expression for the derivative control mode is given by Pt is equals to Kd dEp by dt. We know this is the analytical expression for the derivative control mode. And here this Kd is indicate the derivative gain and this P is indicate the controller output in the percent of full output, and EP is indicate the error in the percentage of full scale range. In the principle, this mode could be implemented by the op-amp circuit present in this figure. So this is the implementation of derivative control mode by using op-amp, or we can say as the analog control. Indeed, the theoretical transfer function of this circuit given by equation number 2 looks just like equation number 1 with the appropriate identification in terms of circuit element is the Vout is equals to minus RC dVe upon dt. So this is the analytical expression for the analog control mode of the derivative. So here where the input voltage has been set equal to the controller error voltage. From a practical perspective, this circuit cannot be used because it tends to be unstable. So this is the main limitation of derivative mode. That is, it may be to exhibit spontaneous oscillation in the output voltage. So that's why we cannot practically use this circuit. So this circuit cannot be used because it tends to be unstable. That means it starts oscillating. That means its output is start oscillating. The reason for this instability is that very large gain and high frequency where the derivative is very large. So this is the reason is given why the oscillation is start in the derivative. Now we discuss about the composite control modes. So, the combination of several controller modes was found to combine the advantage of each mode and in some cases eliminate disadvantage. So we know that while we use this composite control mode, so we get the advantage of other mode and we can eliminate the disadvantage of particular mode. Composite modes are implemented easily using open techniques. Basically, these consist of simple combining the mode circuits introduced in the previous section. Now we discuss about the PI composite control mode. So here this is the proportional and integral controller mode. So we can see this is the summation or the series connection of analog, proportional and analog integral mode. A simple combination of the proportional and integral circuit provide the proportional plus integral mode of a controller action. The resulting circuit is shown in this figure. For this case, the relation between the input and output is most easily found by applying open circuit analysis. So we get this equation for the proportional and integral mode. The definition of the proportional integral controller mode include the proportional gain in the integral term. So we write V out by using this equation. So this is the proportional plus integral mode, and this is the figure for the proportional and integral control mode. Now we discuss about the second one type of the composite control mode, that is proportional plus derivative control. So you can see the diagram of the analog, proportional plus derivative mode in this figure. So here we just combine the proportional and derivative mode. A powerful combination of controller mode is the proportional and derivative mode. This combination is implemented using a circuit similar to that shown in the figure. Analysis show that this circuit responds according to the equation that means this is the equation for the proportional plus derivative control mode, or we can say for the analog PID control mode. Now we discuss about the last one control mode. This is the PID, or we can say as the proportional plus derivative plus integral control mode. The ultimate process control is one that the exhibit proportional, integral and derivative response to the process error input. The analytical expression for the PID controller mode can be given by P is equals to Kp EP plus Kp Ki 0 to T EP dt plus Kp Kd dep upon dt plus Pi 0. We know this is the analytical expression for the PID control mode, and here this Pi 0 indicates the integral term value when T is equals to 0, or we can say initial value of this controller, and P indicates the controller output in percentage of whole scale. Same as EP indicates the process error in percentage of the maximum. Same as Kp is indicate the proportional gain, Ki is indicate the integral gain, and this Kd is indicate the derivative gain. That means Kp, Ki and Kd is indicate the gain of respectively proportional the integral and derivative controlling action. See, this is the diagram of PID controller. That means this is the analog diagram of analog controller, or we can say this is the PID analog controller. The zero error term of the proportional mode is not necessary because the integral automatically accumulates for the offset and nominee setting. This mode can be provided by a straight application of op-amp circuit, resulting in circuit of this figure. It must be noted, however, that it is possible to reduce the complexity of the circuit of this figure and still realize the three-mode action, but in this case an interaction region between derivative and integral gap. So this is the figure of PID controller mode. We will use the circuit of figure because it is easy to follow in illustrating the principle of implementing this mode. Analysis of the circuit shows that the output is given by using this equation. So we can see the controller output or V out is given by using this equation. So this is the final mode, and we can say this is the PID control mode. So in this lecture, first we discuss about the derivative control mode, and then we discuss about the composite control mode. In composite control mode, we discuss first this is the PI, that is proportional plus integral. Then after we discuss the PD, proportional plus derivative, and last we discuss about the PID, that is proportional plus integral plus derivative. Now, in this lecture, I complete this chapter. That means chapter number 5 I complete. In this chapter, there are the few important, most important questions that asked in the G2 exam. Like first we discuss about the classification of control modes, and before that we discuss the various terms that used to define the controller. That means process leg, controller leg. This also asked in the 1 mark question. So the classification of controller is most important. So we know the controller is classified basically in 3 categories. First one is the discontinuous control mode, then after continuous control mode, and last one is the composite control. So here all these modes are very important as per the GTU. So many times this question asked like explain 2-position control mode or multi-position control mode, what is floating control mode, or explain proportional control mode, what are the advantages of the proportional control mode, like explain integral control mode, and sometimes it also asks the proportional composite mode like PD mode and PID controller mode. And it also important the analog controller. So it asks very few, but it is also important. So analog controller we also discussed. The most important question from the analog controller is the explain the on-off controller, or we can say the 2-position controller. So we also discussed the analog. Now in the next lecture we will start